Uncertainty principle. This very principle, proposed by German physicist Werner Heisenberg in 1927, which is in accordance with, in consequence to, the dual behavior of matter and radiation. Both matter and radiation have dual behavior. They behave as a particle, sometimes behave as a particle, and they behave as a wave depending upon their interaction. According to uncertainty principle, it is impossible to determine precisely, simultaneously, both the position and the momentum or the velocity of an electron. It is impossible to determine precisely both the position and momentum or velocity of an electron. If you try to measure the position precisely, there will be error in the velocity, and if you want to determine the velocity precisely, there will be error in the position or the location of the electron. It's impossible to determine both the velocity or momentum and the position or location of electron at the same time. Mathematically, it's represented like this. This represents Heisenberg's uncertainty principle. This delta x represents the uncertainty in position. Delta p represents the uncertainty in measuring the momentum. Will always be more than and equal to h by 4 pi, which is a constant. H, the Planck's constant, has a value of 6.626 into 10 to the power minus 34 joule second. Very small number. It's a very, very small number. Minus 34, 10 to the power minus 34. So something divided by 10 to minus 4 pi. It's coming to 0.5 into 10 to the power minus 28. Extremely small. So the uncertainty in position and multiplied by uncertainty in momentum of an electron will have a value of this 10 to the power minus 28. That's it has a value of this. Momentum means what? Mass into velocity. Mass or uncertainty in velocity will be equal to this h by 4 pi. Well, let's move the mass because it's constant. Mass can never be changed. The mass of an electron will remain same. So let's move it to the other side of the equation. H by 4 pi m. So from here what we have concluding is that, so since this value is very small, this is a very small value, so when it comes to right side, it will be below the line. So the uncertainty in position and uncertainty in velocity will be inversely proportional. If the uncertainty in velocity is less, that means we are trying to calculate the velocity very precisely. If this is less, then this will become more. The uncertainty will, because they are inversely proportional. If this is less, means if you are able to calculate the velocity very accurately, the uncertainty velocity is very low, then the uncertainty position will be very high. And if uncertainty in position is very, very low, if this is very low, then uncertainty in velocity will be very high. They are inversely proportional. So it's not possible to determine both the uncertainty and the velocity with a very precise value. If one is precise, the other will be vague. If one is vague, the other will be precise. Okay, let's try to understand with a numerical figure, with a mathematical figure. For example, if we consider a microscopic object, say milligram, small objects in terms of milligram, which is 10 to the power minus 6 kilogram, the uncertainty in position multiplied by uncertain velocity will be equal to h Planck's constant 6.626 multiplied by 10 to the minus 34, 4 pi 4 into 3.14 multiplied by, suppose it's a 1 milligram object, it's moving, 10 to the minus 6, so it becomes 10 to the minus 28, the whole value. This multiplied by this, the product of uncertain position and uncertainty in velocity becomes 10 to the power minus 20. This is very small figure. So the uncertainty of this kind of object is very small. It's very insignificant, right? But what about electrons? What if these are electrons? This 10 to the power minus 6 will become 10 to the power minus 31. And then this value will increase because 10 to the minus 4 meter square per meter per second and second. Meter per second and meter. This will be, okay, this will be meter, this meter per second. So so the unit will be meter square per second. So for electron, the product of uncertainty in position multiplied by uncertainty in velocity is 10 to the minus 4 for electrons. Very small particle, and the mass is of the range 9.11 into 10 to the minus 31 kilogram. So value becomes bigger. It's much bigger than this. 10 to the minus 28 now becomes 10 to the minus 4. So the product of these two is this. Suppose the uncertainty in velocity, right? Or say in position, say uncertainty in position, delta x is around 10 to the power minus 8. The area around the nucleus, the size of nucleus 10 to the power minus around 10 meter, right? So and say consider 10 to the minus 8. You want to find the error in calculating the position, maybe 10 to the minus 8. If it becomes 10 to the minus 8, if this is 10 to the minus 8, then this will become 10 to the minus 4 divided by 10 to the minus 8, 10 to the power 4. That is 10,000. So the uncertainty in velocity will be around 10,000 meter per second. That means whenever you try to calculate the velocity of the electron, uncertainty in finding the velocity will be around 10,000 meter per second, provided this uncertainty in position is 10 to minus 8. You're calculating inside the vicinity of the atom, so it becomes very significant.